Hello, and this is a live stream of the daily math training, and we're going to be working on the percent word problems. Let's see how far we can get through it. If I get through that, I might do another video of the quiz. But the idea is to use this particular platform to learn how to stay focused on a in particular, learning issue. Like I'm trying to keep up with my, try to focus on graduate school, for example. And graduate school requires you to have a high level of discipline, something higher, something that isn't necessarily required in an undergraduate school. And being an undergrad, you can get away with, just using your best because you're already in the school. And I think that the teachers know they gotta pass a certain amount of people. At least this is what it was, before 2020. I don't know, moving forward, post 2020, I'm not necessarily sure. So this is what we're gonna do. We're gonna have percent word problems and we're gonna just go do it. All right, so John is a quarterback. This year he completed 250 passes with 70% of the passes he attempted this year. How many passes have John attempted this year? 250 passes. 70% of all passes. So these are John's passes. And then here's his total passes. Okay, and then it says here how many passes has John attempted this year. So it would be total passes underscore John's passes. Or what I basically like to do is take this, put that down here. Because what we're trying to do, we're going to divide the total amount of the passes in John's passes to get a fraction. And that would mean that we would say, if we do that, then we would know whatever that is, it's 70%. That's that's the way we can look at it. So we would have to do something. How many passes did John attempted this year? Okay, so I think I'm reading it a little bit different. So total passes, the total completed, let's say okay, I guess that there would be incomplete passes, right? Because in football, you would have incomplete, well, it says here, it says he completed, yes, incomplete passes. I'm gonna write that, incomplete passes. And you have completed passes. Right? And then if you add these two together, that will be the total. That would be the total. And if I erase this stuff at top to kind of get a better understanding. If you add incompleted passes and total passes, it would be the total amount of passes. And then we would know that now we also know that completed passes is 70% of that. So we also know 30, then we know that there's 30%, right? So 30%, and then we also know that's 350. So we know that whatever the 350 plus some number, we can call it X, right? And we can say 350 plus X equals 100% of the passes. So we would have to, and we also would know, we know that 70% plus 30%, right, equals 100%. So basically we would have to do something where we have to find out the total number of passes that the John completed. So we were basically, so what we can go back and say, what is 350 of 70%? I mean, no, not that. It's we know 70% is 350. So we want to know what the 30%. What 30? Yeah. What if that's if 70% makes 350? Then what is the other 30%? You know, so it's kind of like if we're looking at this and we can say this is all it is. This is 70%. You know, but we don't know how many passes he did entirely. So how many passes did he actually attempt this year? I think we could say 350 times 30.30. Well, let me see something. If we know, let's go to let's say he did, instead of him doing 70, let's say him doing 70, let's say he did 75, and that was like 150, right? So that would mean that the other 25% would be 50. So how will we actually find that out? Well, let's say 25 divided by 150, that goes in how many times? How many times is 25 goes into 100 4 times, and 25 goes into just 6 times. 6 times 25 is 150. That doesn't really help us there at all. So we'll try that now. What else could we properly do without having to, utilize the problem solver? How could we deduce this? So 350, if he had 150, passes, if let me go ahead and move all of this out of the way. So you have 350, right? And you have 350, and then you have times, not 350, I'm going to do 150. So we know 75%. If we know that if we had 150 passes, then we know that's 75%, and we want to know how many passes he did entirely. That would mean that the other 25% would have to be 50, because of the fact that 50 is 25% of that. So that's what I'm trying to get at. So I'm seeing that if you go ahead, we put 25, 25, 25, 25, and we have these here like this. That would basically mean that each one is 50 plus 50 plus 50 plus 50. And that would be 50, 50. No, it's not. That's not right. Is that right? Because I know 75. This 75 plus 75 is, that would actually be 150. Oh, okay. Wait. All right. So let me use that. Let me use that. Let me use that. We're going to say that we know that He's like, oh, this year he completed 300, passes, right? He completed 350 passes, and which makes 50% of his other thing. So we know the other 50% would have to be 300. We would know that because 100% is basically in front of the full. It's the total amount of a percentage. So basically, what the other one is. So how would we get that? We can do something like how would I get that? We would need to find that somehow. Maybe we can do 100, right? And then you times it by 1. And to speed up the time, I'm going to go ahead and say, 100 times 1 is 1, right? Which gives us 30. And then we say how many times 30 goes into 50%. All right. Let me find a better answer. So it says that we know that 350% John completed are equal to 70% of the passes attempted. We need to find out the total number of passes, 100% that he attempted. And it says here 350 completed passes. It says, and when we multiply the 50 passes by 10 to see how many passes equal 100%. It says percent and it says passes. And then it says here the total number of passes attempted is 500. So what happens first is that you look at the 350 completed passes, which is 1, 2, 3, 4, 5, 6, 7, 8. Right. So he does something like 350 passes cover 7 of the 10 partitions. And then we divide 350 by 7. So we divide 350 by 7. We divide 350 by 7. Or is it this way? Or is it 350 by 7? Yeah. Not this way. It's actually this. And we would just keep doing the zeros until we get to like that. And then the SEs goes like this. So what happens is this will basically be 350. So how do we get there? We know because 350 covers 7% of the partitions, right? We know 350 equals 70%. We know that. And then we also can tell that 1, 2, 3, 4, 5, 6, 7. Ooh, that's kind of big. Let's go ahead and do this. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yeah. So that means that we would know that how many times this 7? Yeah, we would know 7 times 5 is 35. So we can look at it like that. So this is kind of like we would have to do. We wouldn't be able to deduce it any other way except for by just knowing that if this is 335, we can try to do something like 35 divided by 7 equals 5. Or it actually would be this equal 5, not this way. So that way, I mean, you could use that way too. That way does work. This way gives us, this way would give us 0.5, which is the way we can do it as well. So that's what I wanted to figure out when it comes down to the intuition. It's really important to try to, oops, how many passes did he offend? Oh, this, yeah, okay. So it's 350 plus 400. Yeah. Oh, wait. Then you multiply 50 by 10 to see how many passes. Oh, 500. 500. Oops. All right. So now we go to the next one. Elmer has a collection of 300 fossils of these 21%. Now, my mind wants to go ahead and be like, ooh, 7 times 3 is 21, and 7 times 3 equals 21, and I could start seeing that pattern there. I can also, how many fossilized snails does Elmer have? So I don't want to try to do that. What we're going to do, we're going to say 300 fossils, and we're going to say 21% are fossilized snail shells. And then we want to find out how many fossilized snail shells does Elmer have? Okay. So what we can do from here is, let's go ahead and let's do 21 times 300. If we know 21% of 300 is equal to 70. Something like that. I'm looking at that. So we're looking at this. How many, instead of 300%, it says that this 20% is fossilized. How many fossilized shells does Elmer have? And it says, would be 70. And then if I go ahead and I times 70, 70 by, is this 70? No, 70 by, so if I say 300 times 21, that's not what it is, 20%. Okay, wait. Yes, 300% fossil, and 21% of these is, so yeah, so that would be 63. Okay, so well, basically what I'm looking at, because I'm trying to do all this stuff, how much time do I have? I'm not even like done with the first one. All right, so 21% of this fossilized snail shell. So that's good to see that. So that means like 20%, 21% of 300 is 63. And then it says the other ones are going to be, the other one would basically be, so the other 79% of 300, right? I think that's one way we could look at it too. Is you could 300 minus 79%. It's 299.21. That's weird. If that's true, wait, if that's true, 237. Sorry, I actually did the calculation slightly wrong. So you have 237. So now that we have that, we know that all we have to do is just say 21% of this is 63. 79% of 300 is 237. And then we know 100% of 300 is equal to 237 plus 63. Which is 300. Yeah, I did that. Okay. 237. No, wait, no, we want to do that helps. Okay, you can move on this one. All right, I'm gonna start like writing down stuff. That way it can really help me to pay attention. This is a coin contains 9 grams of nickel. And 16 grams of copper for a total weight of 25 grams. It says, what percentage of the metal in the coin is copper? So they're trying to say that coin equals 9 grams of nickel, and let's use a plus sign. Stay with the mathematical expressions. And you say 16 grams of copper. And then it says here, total weight is 25 grams. So we know that this is 100%, but we don't know the percentage numbers for these over here. If they were even, like even numbers, let's say this one was, how would I do this? 5, 10, 15, 20, 25. I could say this one is 10. They say this one's 10 grams. Ugh, I'm sorry about their handwriting. They say, well, that's 10 grams, and then this one's 15 grams. If we did that, we would, you can instantly see that, oh, this is 20%. And over here, that would be 15%? No. 10, 15, 20. Or it would just be 2, 4. It would be 40% here. And then this would be 2, 4, 6. This would be 60%. Yeah. So that's what we would know that, you know. So that's good to see that. How will we get those things? How will we get this particular system of this particular expression on our own? Let's say we would have 25 divided by 10. Yeah, that makes sense. Yeah. So you go 25 divided by 10 goes in 0 times. And then we put a 0 down here. So 25 goes into 100 4 times, right? And then we could do the same thing for 15. And well, not really 15. We want to do it for see how we like take this function, I create this function here, and then I actually says 1, says 15. Ugh, why I can't think right now. So you have 25, and we do the same thing for 150. And I'm going to bring this down a little bit so that way I can work underneath it. So we say 20 goes into 20 towards the 15 0 times. You dot it, bring the 0 down here. 25 goes into here 6 times. And you see how now we have that whole function. We have this particular function. So this could be our, convert function. We know that this works here. We can take this same thing here and we could just go like this. We just erase this. And now we want to use, we'll plot this function in here. We'll plug it in. We say it's 9, and then this is 60. And then we'll go ahead and move this over here, and move this over here. And then what we do is we say, how many times does 25 go into 60? I mean, 16. And you say 0, and then we bring the 0 down here, right? Dot, and then now we know 25 goes into 160. We know that's almost like 150, which is 6, right? So we could say it goes in 156 times. 6 times 25 is 150. And we bring the 100 down here. We say, how many times does 25 go into 10? 0. And we bring the 0 down. We're already dotted. We're already here. So maybe how many times 25 go into 100? 64. Now that we have that, now what we got to do is say 100 times 64. And that's the 46, 36. Let me just make sure. 54. I don't know why I can't do the math on my head. Like I'm like thinking too roughly. So we know if we do this, right, it's going to be something like that. Why? Because we only have two numbers we're trying to focus on. So I'm going to take this answer and I'm going to hold on to it. And I'm going to say, how many metal is copper? We know copper has 16 grams in it. And we know that 16, whenever it goes into 16, 160, 64 times. So we could say 64%. And there you go. So that's kind of like where I want to go with that. Yeah, it took me a while, but I don't know. In mathematics, I really want to be able to focus more on trying to build like intuition from it. You know, you take what you already know and you apply that to what you're trying to understand. And then once you get something that you understand and you try to understand and what you don't understand, then you try to put something else together and then you try to do something else. And you keep doing this as you go and going forward. You don't worry about time. Don't let people, try to, knock you down because, you do something that's takes up so much time. Time is not really relevant when you're learning. If maybe if you want to work for a company and they really want somebody who can do something like super, super fast, that's great. But when it comes down to learning new things, one thing you really want to learn super fast is how to actually get to the answer. A lot of people, especially myself included, I mean, I was so, bent on trying to do the answers, getting the answers all the time and trying to go so fast, and you would make all these mistakes. And then no one would tell you that. No one would say this to me. This is what people should say. Like, oh, just take your time, break it down to small pieces, and you'll be able to get it done. It's very unlikely that you might run into anybody who may say that to you, but I would definitely take that into consideration. Take whatever you do understand. You know that 5 plus 5 is 10. So you put like something, you put even numbers into it, and after you get the even numbers, then you can just plug it in, just like how a calculator, can answer, can take one or two different numbers that can add larger number that add smaller numbers. The only thing that we are just like a calculator, except for the calculator can compute these things much faster. And that's just basically how I like to pay attention to it, because no one really can do anything fast unless you've done it over and over and over again. That's all you're doing. And it's just that simple. So anyway, I'm not going to go for. I was going to do another version of this, but I'm actually going to just stop, and I'm going to move on to something else. Tomorrow, I'm going to do this. I'll do this again, and then we'll get through it. We're getting through it. I think we have like 2 or 3 more. I probably can get this stuff done probably by this weekend, actually, because all I have to do is this. I'll quickly do the quiz, and then I kind of already have this set up. Oops, I kind of already have this done. So I could just go straight to the quiz for that one. I'll go straight to the quiz for this one, and then I'll do this area of angles, triangles. You know, thinking about what I want to do for my understanding of like arithmetic and stuff. I really want to start focusing on like geometry and trigonometry. I don't know if there isn't any advanced geometry on here. Let me see. And this is KhanAcademy. It's a very good system, and I really enjoy the ideas that come from it. I mean, not because of the fact that I think that this is better than any other one. I just don't know any others that works this. This is one of the oldest ones that does these things, and you know, they even have computing here that you can do. You know, you can have computer science and stuff like that, which is something that they don't have that many. You only have, what have these two? Really? Huh. I could have sworn it was more. I guess because there's so many others that does it, you know, they're not really working too much with it. But before you go ahead and you start taking any advanced stuff, I would definitely, you know, play with these. To me, I recommend these. I don't know about microeconomics. I don't know why I'm doing that. I don't know why I actually looked this up. I don't know. I think I was doing something else. I can probably just move that. Where is it? Macroeconomics. Yeah, just move that for right now, because this is all I'm really working with. Yeah. So thanks a lot. I'm probably going to be making some more videos of the calculus in the future. So prepare for that. Take care. See ya.